Okay, I'm going to go through the test review. I'm going to go through all of the questions so that you know what you're doing for the test. And it's just like it's one page front and back, so it shouldn't be too much time to go through this. So the first thing says the following table shows the average weights for given heights in a population of men. So the heights are in centimeters, the weights are in kilograms. And it says use this data to answer the following questions. So I'm going to type these in. We have 165, then we have 170, 175, 180, and 185. Then for the the weights, we have 67.8, 70.0, 72.7, 75.5, and 77.2. So I'm going to find where those points are. Oh, they're right here. Okay, so those are our points. And A says calculate the line of best fit using the TI Nspire. We're going to use Desmos because we're doing online learning and Desmos is super easy to use. So we have y1 and then we do the tilde mx1 plus b. That gives us our line of best fit, or our regression line. So for this, we are going to write down y equals 0.486 x minus 12.41. And on this one, since the decimals don't go on forever, we can just include everything that it says on here. Next it says use the linear regression equation to estimate the weight of a man whose height is 172 centimeters. So if you notice heights, that's our x. So this is the x value that they want us to plug in. So we're going to do y equals 0.486 times 172 minus 12.41. And the cool thing about Desmos is that we can just type that in. We can do 0.486 times 172 minus 12.41. And that tells us that the weight of someone, the predicted weight of a man whose height is 172 centimeters should be 71.182. And if you look right here, that's where those points would fall, because 172 is between 170 and 175, and then the weight is 71.2 if we round it. So it makes sense. That's a good prediction based on the data that we have. The other thing says use the calculator to find the correlation coefficient. So remember on Desmos, it tells us the correlation coefficient right here, that part that I have highlighted. So the correlation coefficient here is R equals 0.997. So based on that, think back to what we've learned about correlation coefficients. Is this positive, negative, or is there no correlation? So we can see here that this is a positive number. So we know that it's positive. And is this perfect, strong, moderate, or weak? Perfect means that it would be 1. So since our correlation coefficient isn't 1, we know that it's strong because it's 0.997. It's very close to 1, but it's not quite perfect. Moderate is like 0.6 to 0.3. Weak would be 0.3 to 0 if it was anything in between there. So strong, moderate could probably be like 0.7, but it's around there. So if it's like 0.9 or 0.8, that would be strong. Okay, so that's those ones. And then we have part of this that's on residuals. So I'm going to go back to this Desmos here. And I'm going to do what I did in the last video, which was typing in our regression equation, and it'll give us our predicted weight or our predicted values. So I'm going to type in 0.86, 0.486 times x1, so that it takes the values from that first column. And you can see if we don't put in the b, those black points are way above the line. So that's not a good prediction. But if we type in the negative 12.41, it puts them right on that line. So these are our predicted weights. So our first one is 67.78, 70.21, 72.64, 75.07, and 77.5. Now, to find the residuals, I'm going to slide this over. We do the actual minus the predicted. So we do 67.8 minus 67.78. So that would be 0.02. 70 minus 70.21, that's negative 0.21. Then we have 72.7 minus 72.64, so that would be 0.06. 75.5 minus 75.07, that would be 0.43. And then our last one, we have 77.2 minus 77.5, so that's negative 0.3. And then if you printed this out, this will be on the back. On this program, it just has the pages continuous. So on the graph, it says to create the residual plot. So I'm going to put our x values here. I'm going to put 165, 170, 175, 180, and 185. And I'm going to space them out because we only have 5 and there's a lot of grid lines. So I'm just going to put it like that. And then our highest residual value is 0.43. So I'm just going to have this go up to 0.5 and down to negative 0.5, which means that halfway in between would be 0.25 and then negative 0.25. So now using our residuals, at 165, our residual value is 0.02. So that's like super duper close to the line. So that'd be like, I'm actually going to move it a little closer. So that'd be like down there. The next one is negative 0.21. So that's going to be about right there. Then we have 0.06. That's also going to be super close to the line. Then we have 0.43. So I'm going to put that about right there. And then our last one is negative 0.3. So that's going to be about right there. And looking at this, it doesn't ask you to answer this question, but if you're looking at this residual plot, would you say that this is a good, like that the regression line is a good fit, that it follows a linear pattern? Do these points look evenly scattered to you? For me, I would say that this is a good fit because the points are evenly scattered. So the regression line looks like a good fit. The second part of your test is about scatter plots and correlation coefficients, so we don't need Desmos for the rest of the test review. This says match the correlation coefficient to the graph. And the way that I would do this, you have the correlation coefficients listed over here in this area. So what I would do is I'd go through the graphs and see if I could tell what the correlation coefficient is before I looked at what the options are. So for A, this one, we know that it's positive because the slope is going up. And if you look at this, there are no points that are off of this line. So we know that this is perfect, which means that it should have a correlation coefficient of 1. So we're going to look over here at our list, and right here, V is R is approximately equal to 1. So we know that that's A. Then the other one that's pretty obvious is E. This one we know that the slope is negative. And then there are also no points off of this line, so this is also perfect. And if it's a negative perfect, then that's just r equals -1. So that would be IV over here, or Roman numeral 4. So I'm going to put E there. And then on B, this one we know is negative. This one looks like it has no correlation, or it's very weak. D is positive, and F is also positive. So we've already done Roman numeral 4 and Roman numeral 5. So we have negative 0.74, 0.331, 0.89, and 0.61. So the only one that's negative here is Roman numeral 1, or I. So we know that that one has to be B. And it makes sense. If we were to draw a line here, the points are pretty close to it. So it would be like a strong to moderate correlation, which makes sense that it's negative 0.74. And then the weakest one is C. And then the weakest correlation, or the smallest correlation, is 0.31, because we have 0.31, 0.61, and 0.89. So this one would be C, because it has the smallest correlation. And it says that it's positive, so the correlation, well, the regression line could be something like this. And because it's positive, so, but it's very weak. And then we have D, if we drew a line for D, and if we drew a line for F, which one has the stronger correlation? Obviously, we can see that it's F, because the points are a lot closer on F. So this one is 0.89, that's the stronger correlation, and then 0.61 would be the weaker out of the two. So that's how you should fill out this section, and you'll have something just like this. You'll have 6 graphs, and you'll be matching the correlation coefficient on the test just like this. It'll have drop-down boxes since it's on Canvas, but it's the same idea. And then the last question is asking you to identify which of the following residual plots shows a regression line that is not a good fit for the data. So remember, if it's a good fit, the points are randomly scattered and there's no pattern. So here on A, the points are randomly scattered. So I'm going to put a check. It looks like it's a good fit. B, it looks like it's a good fit. They're randomly scattered. C, if you look at this one, it kind of has a curved pattern, kind of like that. And then D, they look pretty random. So on this one, if it has a curved pattern, then that's not a good fit. That shows that the regression line is not a good fit for the data. So I'm going to put C. And then for the explanation, I'm going to put it's curved. So this shows the regression line is not a good fit for the data. Okay, and on your test, you'll have to write a sentence on why you picked the graph that you picked. It'll be different graphs, but it'll be the same idea. So that's your test review. As soon as you're done going through this, I would recommend going and doing the test so that it's all fresh on your mind. You have one chance or one attempt to do the test, but you have an unlimited amount of time, so take all the time you need. And this will be going on your 4th term grade, so make sure that you do your best. Good luck.